Suppose the range of a function f is -5 to 8. What is the range of the absolute value then of f of x? All right, so this question seems a little challenging. I think what would make it easiest is if we drew a little graph, all right, a little coordinate system. So let's pretend that down here is -5, okay, and all the way up here is going to be a value of 8. And let's also make up now what the function looks like. I don't know what it looks like, but it might look something like this. All right. I'm just going to make like a straight line here, and then another straight, and then not another one, but these are both part of the same line. I'm just making it in two different pieces because I want to illustrate something. So this right here, and what I'll do also, just move this 8 down a little bit because it doesn't look like it meets it. But if this were my graph or my line, right? Notice how it goes down to -5 and it goes up to +8. So this function would have a range from -5 to 8. All right. Now the question is, well, what happens when we take the absolute value of this graph? Well, remember down here that the absolute value of a certain number or a function or whatever, I called it x, all right, basically turns all the negatives into positives. So notice in this region you have all negatives, okay? So essentially what's going to happen is this whole region will be converted into positives by the absolute value itself. So what that looks like graphically is actually this. What happens here is that we get a reflection basically in the x-axis. So where this side will then live up here. And I should put it a little lower, okay? Where it will now be at +5, okay? Remember the graph was here before, and now I reflected it on up. So the -5 value here turned into be a +5, right? Let's pretend that this value right, in this location was a -4. Now it's a +4, -3, +3, -2, -2, etc. All right, all the way down to 0. If I take the absolute value of a positive number, does it do anything? No, right? Because it just turns the negatives into positives. So whatever was, if this point right here was +2 before, it's still +2. All right. Now notice, if you had this function now in this graph, what would you tell me the domain is? Excuse me, the range. The range, remember, is the lowest value that y can obtain all the way to the highest. So the lowest value it can obtain is actually now 0. The highest value is still 8 though. Right? So I would say now the range of this thing is going to be from 0, I can say inclusive of it, okay, inclusive of 0, all the way to 8 inclusive. Remember, they gave us those brackets to start also, so I know that the 8's inclusive because of the bracket up there. And the 0 falls within this range, so I know it has to also be inclusive of 0. So this is the range. All right, that's all. Then let's take a look at the next one, right? It says create a function now in which the range is all non-negative real numbers. So I think you might have an idea, right? We just kind of piggybacking on the prior question about absolute value, right? Pretend I had this function, f of x is equal to absolute value of x. What would that look like? Right? Well, that would look something like this. I mean, you can throw it into your calculator if you like too, but it would look something like this, that let's pretend x were 0. What's the absolute value of 0? It's also 0. So that's a 0.00. What happens if I plug in a -1 for x? What gets spit out of the function? Well, you take the absolute value, that becomes a +1. So I go -1 to +1. So I put a point there, okay? So I put a point right here. How about if I plug in a -2? Again, it turns it into +2, so that's going to be a point here, and you're going to see the pattern. What happens if I plug in now a +1? Well, a +1 gets spit out, so the coordinate's 1, 1. What happens if I plug in a +2 for x over here? It spits out a +2 for y, so that's there. Notice what the graph is going to look like. It's actually going to look exactly like what we had. It's going to look exactly like what we had before. Okay, a V shape. So here, this will go on forever, all the way from 0, which is non-negative, all the way out to infinity. Okay, so the range here, what they're asking for, is to go basically from 0 all the way out to infinity. And that's what we just showed. All right? And last but not least, let's take a look at the last question here. It says create a function in which the domain is x greater than 2. Okay, so you might say x has to be greater than 2. All right. So, I know maybe something like, I don't know, right? Maybe something like a radical function we could use, right? So pretend we started off with this. So we had a radical of x minus 2. This sounds great so far, right? Because I know I can't take a radical of a negative number. So I know that x here has to be at least 2, right? If it's less than 2 here, like 1, this whole value becomes negative and that's no good. But what's the problem here? The problem here is that this function by itself, the domain of this thing, okay, would be from inclusive of 2 all the way to infinity, right? In other words, using the interval notation, it would be x greater than or equal to 2. But I don't want greater than or equal to, I want greater than, just greater than. So we can deal with something like this, but we might have to put it in a different location. For example, what happens if I were to now, let's say, flip this thing? Flip this thing. In other words, put it under 1. Now what happens? Well, can x be 2 anymore? Well, if you plug in a 2 here, this becomes a 0. The radical of 0 is 0. But what's the issue there? You would be dividing by 0. No good. But, right, so that, okay, great, that doesn't include 2. How about then, though, 3? Is 3 okay? Of course it's okay. Right, 3 minus 2 is 1, radical 1 is 1, and you can divide 1 by 1. As you can see, we have now created a function that now follows, our constraint. Okay, so this right here, ladies and gentlemen, is indeed a particular function. I'm sure you could challenge yourself, try to find a couple other ones. You definitely can. Thanks for tuning in. Please remember to subscribe. See you next time.